Question 33, lambda. Here we are asked to determine the angular velocity, so we are going to focus on this. So from here you can see where t is, so we'll just compare this with this. So by comparing, you see that it's 500, and that will give us 5.0 times 10 to the power 2 radians. So that's the correct answer for that. Okay, question 34. If sound wave goes from a cold air region to a hot air region, its wavelength will. So we want to know what will happen to the wavelength. Now let's see, we know that V is equal to F times lambda. So it means that the speed is directly proportional to both the frequency and the wavelength. Now if we keep the frequency constant and we increase the wavelength, then the speed will increase. That's what it means. Now when sound goes from cold region, air region to hot air region, this speed increases. So if the speed increases, because the speed of sound wave in air depends on temperature, it decreases with the increase in temperature. So if the sound wave is going to increase, the speed of the sound is going to increase, then the wavelength is also going to increase, because from this formula you can see that V is proportional to what? The wavelength. So it's going to what? Increase. Now the lowest note, number 35, the lowest note emitted by a stretched string has a frequency of 40 Hz. How many overtones are there between 40 Hz and 180 Hz? Okay, for a stretched string, the harmonics are combination of odd and even. We have even and odd combinations of harmonics. So the harmonics are F naught, 2 F naught, 3 F naught, 4 F naught, and so on. So continuation like that. Now this is the first harmonic, this is the second, 2 F naught is the second harmonic and the first overtone. 3 F naught is the third harmonic and the second overtone. So we ask how many overtones can we get between 40 and 180. So we have 40. So if we multiply 40 by, if I multiply 40, so the next harmonic harmonic is going to be 80, which is going to be the first overtone. Then the next harmonic is going to be 80 plus 40, that's 120, which is going to be the what? The second overtone. And 40 times 4, that's going to give me 160, which is going to be the fourth harmonic or the third overtone. The next harmonic we are going to get there is going to be 5 times 40, which is 200. So between 40 and 180, we are going to have just 80, 120, and 160 overtones. So we are going to have 3 overtones. But the actual number of harmonics we are going to have are 4. We are going to have 4 harmonics, but 3 overtones, which is what the question is asking us to look for, the number of overtones. So these are the overtones. The first overtone 1, the second overtone 2, the third overtone. The next overtone, which is the fifth harmonic, is going to be 5 F naught, which is the fourth what? Overtone. Okay, next. A man stands 4 meters in front of a concave plane mirror. If the mirror is moved 1 meter towards the man, the distance between him and his new image is, now let me just illustrate this. This is a plane mirror. Okay, one side is silvered. Okay, a man stands 4 meters. Let's say this is the man standing 4 meters in front of it. An image will be formed 4 meters, which is erect and laterally inverted in front of the mirror. Now if I push this man this way, 1 meter, 1 meter this way, then the distance between him and the mirror is going to be 3 meters. Then again, the image is now going to be formed, going to move closer to the mirror, 1 meter on this side. So the distance between the mirror and the image is 3 meters. So if you combine the two of them together, that's going to give us 6 meters. 3 plus 3 is what? 6 meters. the inside portion of part of a hollow metal sphere of diameter 20 meter is polished. The portion will therefore form. Now, this is one question that I've seen that has even given professionals some kind of problem. Some people do not understand that a polished side of a mirror is the reflecting side. Some people think that the side that is polished is actually the silver side. No, a reflecting surface is always polished and shining. So the side that is polished is the reflecting surface. So if I have a metal sphere of diameter 20 cm, so if I have it, let's say I have this, and the outside is polished, is silvered, because we are told that the inside is polished. So if the inside is polished, the inside is the reflecting surface. This is a concave mirror. This is a concave mirror of radius of curvature 10 cm. Why did I say that? The diameter of the sphere is 20 cm. To get the radius of the sphere, you divide 20 by 2. That leaves us with 10 cm. I'm coming. Okay. So if the diameter is 20 cm, it therefore means that the radius of curvature will be 10 cm. It's going to be 10 cm, and you know that the focal length is going to be equal to the radius of curvature divided by 2. So 10 divided by 2 is equal to 5. So the focal length is 5 cm, and since the east side is polished, the outside is silver, so it's a concave mirror of focal length 5 cm. So the correct option is option A. The velocity of light in air and glass are 3.0 times 10 to the power 8 meters per second and 2.0 times 10 to the power 8 meters per second. If the angle of refraction is 30 degrees, the sine of the angle of incidence is, okay, now you know that the refractive index is equal to the sine of incident ray over refracted ray. It is also equal to the speed of light in air divided by the speed of light in glass. So we have this. Now the next thing you have to do, you remember that we are told that the angle of refraction is 30 degrees. So sine arrow is actually sine 30, and sine 30 is 0.5. So from here, this will cancel out this. When this cancels out, this 3 divided by 2 is 1.5. So I'm going to have sine I over sine 30 is 0.5 is equal to 3 divided by 2 is 1.5. 1.5. So sine I is going to be equal to, I'll just cross multiply from here. When I cross multiply, I have 1.5 times 0.5. That's going to give me 0.75. An astronomical telescope is said to be in normal adjustment when, now for all telescopes, they are said to be in normal adjustment when the final image is formed at infinity, at a very far distance. That's what it means. So the correct option is option what? D. So let's go to question 40. So for question 40, a 2 Henry inductor has negligible resistance and is connected to a 50 divided by pi hertz AC supply. The reactance of the inductor is, now the reactance of an inductor is given as XL, X sub L is equal to 2 pi F L. Now you see, we can just substitute these values here into this. Now I'm going to have 2 times pi times F, the frequency F is 50 divided by pi times the inductance, which is 2. So you see that pi will cancel out pi. We are left with 2 times 50 is 100, and 50 times 2 is 200. So the reactance of the inductor is 200 ohms. Okay, So that will be all for today's video. Do stay tuned for more exciting videos coming in for mathematics, physics again, and even chemistry. So don't forget to leave your comments in the comment section, as we look forward to entertaining your opinions and your suggestions. Thank you very much. See you some other time.